Hi everyone, welcome back to my channel. I am Praful and today we are diving into Apache Kafka, a powerful tool which is widely used in the world of data streaming and stream processing. So whether you are a beginner or you are prepping for an interview, this video is just for you because by the end of this video, you will be having a strong understanding of Kafka and you will be able to answer any question in the interview related to Apache Kafka very confidently. And apart from this, I have also something for you. Like after this video, I will also bring another video where I will implement Kafka using Kafka with Python, and we will build a kind of project using microservice architecture. So you can add that project in your resume, and it will be having a great impact as you have used Kafka in your personal projects. So that video will be next video. So let's start this video without wasting any time. So let's move to the documentation page of Apache Kafka and let's get a tour of this. So it is mentioned that Apache Kafka is an open source distributed event streaming platform. So I will explain you just after this documentation page that what does it really mean. But for now, just see that it is an open source distributed event streaming platform, which is used by thousands of companies for high performance data pipelines, streaming analytics, and data integration. And I will explain you each of these things. So please don't worry. So for now, just let's get a look. And you can also see here 10 out of 10 manufacturing industries are using Apache Kafka at some point in their applications, and 7 out of 10 banks are using this. Insurance field, 10 out of 10 companies are using Kafka at some point, and in telecom, 8 out of 10. So you can see how much popular it is, and it is initially it was developed by LinkedIn, but now it is maintained by Apache. So this is the introduction to Kafka, that it's an open source distributed event streaming platform. But now let's understand why do we need Kafka and what problem exactly it solves, and why do we call it event streaming platform. So I will explain you everything. So let's move to the problem. So let's take example of Netflix and understand the problem which occurs and that is solved by Apache Kafka. So what happens? Netflix has a recommendation engine which recommends movies in real times or contents in real times to the users. So for that recommendation, what it does, user interacts whenever a user interacts with their platform. Like if a user searches for a video, if a user starts any video or pause any video, plays any video, skips any video, all these micro interactions are recorded by Netflix. And if you don't use Apache Kafka, everything will be recorded in database, and then these records will be fetched by these engines, recommendation engine, and then it will use any algorithm to suggest you the next content. But uh, try to understand the problem. All these events will be recorded every time. So in a second, there will be millions of users and there will be millions of micro interactions which will be happening on every second. And our database will be hit, we will hit our database in every second millions of times to just record these micro interactions. And it will be very efficient, and our database might crash very soon if we do so much operations in a single second and in every second, and then we are also fetching it from database. So this will be no more real-time recommendation engine because there will be some latency to put data in database and fetch in from database. So this is not going to be a real time, and I also explained you the problem that we cannot do lots of millions of operation for every second to store these micro interactions. Now let's understand how does Kafka solve that problem. So all these events which were performed by this user, it will Netflix will pass all those events to this Kafka queue. It will be a kind of queue, or you can say a service, let's say service for now. All those events are directly passed here, and Kafka is very much fast and efficient. That's why I called it like high throughput. Means you can insert many things, millions of things on just a single second. You can put many messages here, and it will be able to store all those things for a certain period of time. So as soon as any interaction will be done, any micro interaction, it will be recorded into this queue, and then it will stream all those things, all those data. These yellow colored boxes are topics, which I will explain you later. So let's say a message is passed, any event is passed in this queue, Kafka, then it will be these are subscriber to those messages, database and the recommendation engine. So recommendation engine is real time, so it will directly get that message and it will recommend content in real time. But for database, what we will do, we will we can add a kind of cron job which will insert the bulk of interactions. Like after every 10 minutes, we are going to store all the interactions which are done till now in 10 minutes. We are going to insert them in bulk in just one operation. We can do this in one operation. So we are making our database efficient. We are saving operations and we can insert all those data in just one insert. So our database is also subscribed here. So the Kafka will store like these micro interactions, these events for some time, and after some time we are going to insert using a bulk insert in our database. So it saved our database operations and it also maintained our like real-time recommendation engines. So that's how Kafka solved our problem. And this is called event streaming, where you have streamed all those events like play, pause, search, and start a video. All those events are passed in this Kafka, and the events are streamed directly to the recommendation engine in real time, and it will be totally real time because there will be no latency to insert data in database and fetch from database. It will be a real time and it will be much faster and with high throughput. And there will be low the Kafka is also fault tolerance, and I'll explain you later in this video how it is fault tolerant. So this is the example of Netflix, and there are like thousands of use cases of Kafka which I can explain you. Like Uber uses Kafka, BMW uses Kafka, Spotify uses Kafka. There are lots of companies which are using Kafka to solve their own problems. And I will explain you one more problem which will be of Spotify, so that you will be getting a better understanding of how does Kafka work. So this is how Spotify uses Kafka in their case. Suppose an artist published a song, it goes to the queue, Apache Kafka message queue, and the song like it is published here, and then all the services which are subscribed to this topic, like a publication of a song. So all the services which are subscribed to this will get notified and they will receive the message that a song has been published. So suppose there is a notification service which sends notification or if a song is published. So it will send notification to the users. There is recommendation system which recommend songs to the users. So it will use that song in their case. And there is another service which is using which is tracking the activity of the users. So it will track the activity of this artist. So like all these are different and totally independent services which are using Kafka messaging queue for interacting. So this is a kind of microservice architecture which is used by Spotify. This is not the exact architecture of Spotify. I'm saying this is just an example to explain you how does Kafka work. So let's move ahead and understand the architecture of Apache Kafka. So there are three main things: producers, consumers, and the cluster. So what happens? Consumers are those services which are producing events or which are producing data and messages, and these data will be streamed into the cluster. So producers are those services or those entities which are producing some kind of data or message which has to be used by other services. So they publish their message in the cluster, and then the consumers are those services which are using those streams or data to perform some actions or to do whatever they want. So I'm going to show you with this example. So in the case of Spotify, the artist was a producer because he was publishing a song, and that the message that a song was published is passed into that Apache Kafka cluster or queue, and then that message has to be consumed by these notification services because that message will be consumed and the notification will be sent, and then according to that message the song will be recommended. So these are consumers. So now we have understanding of producers and consumers. Now let's understand the cluster. So first, the first thing we have is a broker. So broker is like nothing, but it maintains all the requests which are coming from producers and all the requests which are coming from the consumers. So breaker maintains all those requests and it has some kind of metadata of clusters, and it also helps in replication of the messages because as we all know that Apache Kafka is a fault tolerant. So we replicate our data in different brokers so that in case of failure of any broker, our data will be persistent and it is not lost. So that's why we have different brokers. And then we have like topics. A topic is nothing but logical group of things, activities, or you can say logical group of events or data. For example, you are building an e-commerce website. So there might be different kinds of events like ordering of a product, payment of a product, or you can say recording the activities of that user. So these can be three different kinds of topics. Like the first can be orders, second topic can be payments, third topic can be recording activities. So these can be different topics, and a topic can be divided into different subtopics, which are called partitions. So we divide our task into different subtasks, which can be performed using parallelism or multiprocessing for better, faster processing. So it increases our scalability. So partitions are nothing but smaller chunks of the same topics, which are consumed by the consumer groups. So this is how the whole architecture of Kafka looks like. But now I will tell you that Kafka can work as both as queue on a queue architecture, like as a messaging queue, or it can also work as a pub/sub architecture, like publisher and subscriber architecture. So publishers are those who produce messages, and subscriber are those who are consumers who are subscribed to that messages, and they work with that message, that events, that data, and that's how it works. Everything works. And the zookeeper is something which takes care of the brokers if any broker fails, or if any new broker is added, if a new broker is removed. So it takes care of all those things. But in latest updates, we can also avoid this zookeeper. There are some updates here, so that you can check out. Now, as we know the architecture of Apache Kafka, let's just see the life cycle. How does it work? So producer produces a message which is going to be stored in a partition inside a topic, and then the consumers which are subscribed to that partition will consume that data, the message, and then perform some actions. And if the consumer made any change in that data, that change has to be stored again, but with a offset. So there is a concept of called offset in Kafka, which ensures that the data is durable. Like it writes like you can say a kind of priority number when this data has been updated. So it sets a number when the current data has been updated, so that the data has been fetched in a linear way, and the data has to be persistent. So this was the concept for offsets. That in simple words, whenever you update a value in a partition, we have to enter the number that this is updated now. Like the first time when you update, you will write 1. The second time when you will update, you will write 2, 3, and many more. So this was how offsets work. Now I will explain you one more thing. Like a partition can have multiple, you can say one partition can have a single consumer in a group. If you have a consumer group, then of one consumer can have one partition can have only one consumer. So if you want to if you want to have more consumers for a single partition, you need to build different consumer groups. So suppose if this was a consumer group, then you need to if you want partition A to have different consumers, like more than one consumer, then you need to create a different consumer group. Then that group will be assigned that partition. So this is how you can make it a pub/sub architecture, like publisher and subscriber architecture. One publisher can have many subscribers. And if you want for a single partition to have a single consumer, it will be a queue architecture. In addition to this, let's see the common use cases of Apache Kafka. Like where do we really use them? So the first one is real-time analytics. So Kafka is a perfect for processing streams of real-time data for analytics. The common example can be for this will be Ola or Uber, where you can see the real-time updates or location of the driver or the passenger. As you can see, the other examples can be Zomato, where you can track your order in real time. So this is where you can use Apache Kafka to like process different bulk events in a shorter time. Now the second one is data integration. So Kafka acts as a central hub for data integration between different systems. So if you are building any system which this can be commonly used in banks, where the data has to be integrated, where different services are interacting with the same data has to be updated every time in real time. So where here you can use Apache Kafka for common data integration between different systems. The third one is microservice communication, which the example that I earlier given you of Spotify is a great example for this, where Kafka is great for asynchronous communication between microservices. Like if different microservices are wants to interact with each other in asynchronous way, they can use this Apache Kafka as a great tool for them. And the fourth one is event sourcing. Kafka can store events that can be replayed to rebuild application state. So you can store different kinds of event to get back to the original state using Kafka. And I hope you have got a better understanding of how Apache Kafka works. What does it mean? What are producers? What are subscribers? What are clusters? What are partitions? What are topics? You got understanding of all these things, and now you know where do we need to use Kafka, which kinds of problem do we solve using Kafka, and now you can use Kafka in your projects if you think you require it. So whenever you have to build a software kind of Zomato, Uber, Ola, or you want to like stream a bulk amount of events or data in your application, you can use Apache Kafka without any hesitation then. So this video was all about Kafka. I hope you liked it. So please make sure you like our video and subscribe to my channel for the next video, which is going to be the implementation of Kafka with Python. So bye guys, see you.